plus 4i to become just I or 1i.
Mhm.
And then you can do the same thing with the numbers there. 5 minus 2, that becomes 3.
Right.
So notice your final answer is letter B.
Mhm.
Any questions on that?
No.
Okay.
I already know the answer to 18.
Okay. Do you want me to check it, or do you feel like you've got it?
Check it maybe.
Okay.
The answer is A.
Okay, so this I to the 5th becomes I to the 4th times I to the 1st power, and I to the 4th is equal to 1. So this negative comes down. So the I to the 4th becomes 1, and then the I comes down, and it's just negative I, like you said.
Yeah.
Good. I would encourage you to try and do as many of these as you can on your own. That will certainly speed up everything that we're doing here today, or in general. And the more we work together, the more that will happen just naturally. You'll just say, oh, let me just try a few more. You'll be working faster. Okay, this one we have to FOIL.
Oh, lovely.
And we did this yesterday. So I'd like you to try foiling it on your own here. If you're really stuck, I'd be happy to help. But first, outies, innies, lasts. You've done this before. So go ahead and see if you can work that one out on your own, please.
Okay. So far, what I've gotten is hold on. So far with the foiling, I got 6i plus 9 minus 2i squared plus minus 3i.
Perfect. Okay.
Yeah, I was about to say plus, and I'm like, no, that's minus.
Okay, so kind of like earlier, you're going to combine like terms here, like 6i and minus 3i, that becomes plus 3i.
Mm-hmm.
And notice that gets you down to either A or B. Okay. So you should always kind of look ahead and just say, well, I wonder, what can happen here. Do you remember what the value of I squared is from yesterday?
It's 1.
-1. I to the 4th is +1. So what that does is this right here, this 9 minus 2i squared, it becomes 9 minus 2 times -1, because I squared is replaced by -1.
Mm-hmm.
You multiply before you subtract. 2 times -1 is -2. 9 minus a minus 2 is 11. And there you have it. You bring this down. There's your final answer on that.
Mm-hmm. So that's A.
That is A.
Yes.
Let me know when you get that down, and we'll move on to number 20.
Okay. Okay, I'm ready.
All right. So number 20 here, I'll snip in the multiple choice here after we've done some work on this. The underlying requirement here is that you will be factoring. You'll be factoring this quadratic here. So 4x squared plus 15x plus 9 without the inequality. We'll get back to that. This type of factoring, it has the appearance of a perfect square trinomial, but it is not, and it's kind of deceptive because the middle term doesn't work out as far as that goes. So when you have a number in front, you take that number and you multiply it by the last number. You have to multiply 4 times 9, which is 36. And now what you're looking for are two numbers that multiply to 36, but add to positive 15.
Mm-hmm.
Okay, so the choices here are 12 and 3. And what we do next is we take this 15x and we break it apart as 12x plus 3x and bring the other stuff down. 4x squared plus 12x plus 3x plus 9. So notice we haven't actually done anything in terms of like factoring. We're just breaking apart this middle term.
Mhm.
And we can get into why we do this, but for now, let's just go with it because I don't know where you're going in this course. So it might be that we don't need this factoring anymore for a while.
Mm.
Okay. So now we're going to look at the first two terms here. And we're looking for the GCF, the greatest common factor between 4x squared and 12x. Do you remember GCFs?
Yeah, they're usually the highest number.
So it has to go into both. So think of it, is there a number that goes into both 4 and 12?
Yes.
So you typically try the smaller number. 4 goes into 12. So we know that it's a 4, okay? And then you look at the two variables, the x squared and the x, and you look for the smaller exponent.
Mhm.
What's the smaller exponent?
It's 2.
The
Well,
smaller one.
smaller one?
Yes.
Or-
The 1. We're looking between the 1 and the 2. The 1 is the smaller exponent.
Oh yeah.
Okay.
Mhm.
So 4x. Now, it sounds like you haven't seen this before. That's okay. We're only going to do this one, but there's kind of a lot that goes into it. They didn't do any favors here. You now divide each of these by the GCF.
Mhm.
All right. So this GCF is 4x is 4x. You're dividing 4x squared by 4x. 4 divided by 4 is 1. X squared divided by x is just x. 12 divided by 4 is 3. X divided by x is just 1. 3 times 1 is 3. This becomes x plus 3. Okay. Now, the second part of this factoring is you immediately write what's here off to the right here. So whatever's in parentheses also goes over here to the right. And now you have to figure out what goes in here such that when you multiply in, you get back to the previous line. Like what would you multiply 3 by to get back to 9? Maybe you're getting caught up here. It would be positive 3. 3 times x is 3x. 3 times 3 is positive 9.
Mhm.
Okay. Now notice that there is an x plus 3 in both of these.
Mhm.
Okay, so what that means is you can actually factor out an x plus 3 from both. It's a GCF again. And then you bring down the other stuff, the 4x, and then the plus 3.
Mhm.
All right, and now we can set it equal to 0. Like the whole point of this factoring was to get it into two binomials that you can set equal to 0. You can set x plus 3 equal to 0 and 4x plus 3 equal to 0.
Mhm.
Okay, could you solve each of those for us, please?
Yeah. For the first one, x will be -3.
Good,
And for the second one, just give me a second. X equals -3/4.
good. So here's what we've been doing. We draw a number line.
Mhm.
We put the 2 points on the number line. And then we have to test. We have to test points. And so why don't we test like -4, -2, and 0. And you can actually test them in the original. You can test them in the factored form, whatever you think.
Okay. Put these all in a calculator.
Yes, good choice. Make it go a little faster.
Here, the Desmos is strong with this one.
Yes, you're a convert now. You know right where to go.
Yeah, that's me. This much is not working today. So -4 plus 3, and then I have to put it. Oh wait, hold on.
And then you got to put in the other one as well.
Yeah, so that means it's gonna be like 4x times the -4, basically. I think I'm speaking nonsense. I got +13.
Okay, now try -2.
Okay. -5.
Okay, and then the last one there, 0.
One is a 0. Okay, +9.
Okay, so positive there. Now I'm going to snip in the question again. And notice we're looking for where it is greater than or equal to 0. Sorry, I'm trying to get the highlighter. Greater than or equal to 0. So we want this region on the left, this region on the right. Do we include -3 and -3/4? Basically, that's this, based on this symbol down here. Do we have a filled in or not filled in at the top on the number line?
No, we don't have a filled in.
So the symbols here, these always go with the filled in, and then these go with the filled in as well, the brackets. And then if it's just a greater than or less than, that's the open circle. They go with parentheses.
Mhm.
So what I'm seeing here is that it's all the numbers less than or equal to -3 and all the numbers greater than or equal to -3/4. All the numbers to the left, all the numbers to the right.
Mhm. All right, thank you.
Okay, so take a deep breath. We are on to a new lesson here.
Yep, with 10 questions this time. We got a little bit blessed.
It's it looks like there's a pattern here of they always give you 10, which could be good or bad depending on how long they are.
Yeah, oh my god. I submit the review lesson, right? I submit the lesson before we're starting on the new one. My teacher respond at the speed of light, and we just got our grade already.
Oh wow, good,
Yeah, all of them are correct.
good. That's great.
I just
So
want to say, we had more A's and B's as our answers than D and C's.
well, you maybe point that out. So I need a tougher math quiz if you're gonna test me.
Please don't. I know. Quizzes are not my favorite, and they make me cry.
Yes.
I've cried from too many math quizzes in my life.
All right. So let me know when you are ready to begin here. We've got a new topic area. Looks like you're talking about functions. What makes something a function?
Okay, I'm ready.
All right. So I have to give you just a tiny bit of background on this before we can do it. But a function is the following: for every input, there is a unique output. Okay, and what that means is that if you imagine this represents your input, and this represents your output, and let's say this is your input. What if A went to 2 different values? That would be really weird because you don't know whether it's going to go to this one or this one. So it's unpredictable. And functions are supposed to be predictable. You shouldn't have to wonder what's going to happen.
Yeah.
Okay, now in terms of how to actually do this problem right here in front of you, I'm going to give you some some guidance here. So what you're looking for, the first thing you're looking for are duplicates in X. So look at just the X values, and do you see any duplicates?
I see one's a duplicate.
Just in the X values.
Oh. No, I don't. Well,
Okay.
we can doesn't say 2 and -2, then
It's got to be exactly the same.
yeah, then no.
Okay. So no, there are no duplicates. The good news is that this means that if there are no duplicates, that means that it is, you can say, yes, it's a function. Okay. But you want to add the following that I wrote before, which is for every input, there is a unique output.
Mhm.
Let me correct that spelling there.
Should I write that in my problem saying for every
Yeah, I would add that. I would
Yeah.
add that.
Right, I'm writing that real quick. Because maybe my teacher will need that. That's important to me. All right.
All right, so for number 2, referring back to the same question, I'm going to snip in the data points one more time. All right. All right, given the relation number 1 above, determine the domain and range. The domain are the X values. The range is the Y values. Okay, so let's first look at the X values. 2, -5, 0, 5, and -2. All right, so I'm just writing them down. The preference for writing the domain now is to use these things on the left and the right. These are called curly braces.
Early.
And curly braces, yeah, and they're on your keyboard. I don't know what kind of, if you're using a Windows or Mac, but they're kind of next to the P on the Windows there.
Oh yeah.
So you always start with an open curly brace. The one that opens, that one that on the left here is an open curly brace, and then you're supposed to put them in increasing order. So this
So
means
like lowest to
lowest is
greatest.
exactly. That's if you want to be that A+ student. If you don't care, you can just give it to it up here.
I'll be that A+ student.
Good choice. All
Like
right.
2 math courses this year. This is the second course I take that as a what grade am I in?
So for the range, it's the Y values. So again, I'm just going to write the Y values without thinking much about those. And then for the range, you do the same thing. You put them in order, but notice you have duplicates now.
Mhm.
So you did not include the duplicates.
Okay.
You just write one of them.
Okay.
So I'm sorry, we start with -8, -8, comma 1, comma 4, close curly brace.
Curly braces are so hard to draw.
Yes, so there is some symmetry to them. They have kind of this shape for the top, and then if you can imagine flipping it, they have the same shape on the bottom, just flipped.
How are you? That's such a perfect wow.
Well,
You're
if you draw enough of them, you will get it. You're not graded on your ability to draw curly braces, so just just get down, something.
it is annoying to draw because they have to look a specific way. It's a struggle. I also am caught up, by the way.
Okay. Number 3, it says to look at the graph and determine if this relation is a function. So there is what's called the vertical line test. Okay, and what it says is that a vertical line will intersect the graph or curve, we should maybe say curve only one time.
Mhm.
So I'm going to come off to the right here and redraw the curve. Okay, and it's got to be a vertical line. Does that hit it one time?
I'm sorry, what?
Does that vertical line hit the graph one time?
Yeah.
Yes. Now, if I move it, does that also hit it one time?
Yes.
Yes. Okay. So you might be wondering, well, well, we'll get to that. So this, yes, this is a function. And then you would say passes the vertical line test.
Mhm. All right, I'm caught up.
All right, so for number 4, I'm glad they've got number 4 here, because you should see, well, what does it look like when it does not pass the vertical line test?
Why is it an oval?
Well, there are graphs that are oval. There's graphs that look like a lot of things, but if you draw a vertical line here, how many times does it intersect the curve?
Like twice?
Twice. So this does not pass. This is not a function. Not a function. Does not pass. And then some students like to shorten the vertical line test to VLT, for vertical line test.
Okay.
All right. So there's 2 types of problems you'll see. One is, or sorry, 3 types. One is they'll give you a data set. The other is they'll give you a graph. The third type, which we haven't seen, is where they actually give you some letters and you have to decide whether it's a function or not. Okay. All right. So ready to move on to number 5.
Yeah,
Here we go.
been born ready.
Yes. All right. It says to determine the domain and range of the following function and explain, show your work, provide a graph to verify your answer. All right. So this is, we haven't done this yet, but let's do a quick overview of Desmos to maybe help you graphing with this. So I'm going to go to Desmos now. I'm going to share my screen and give you just a brief overview of how to use it here. You said you've used it before, but
Yeah.
maybe we can all sketch you to like this a little better. So you type it exactly the way that you see. Now, if you prefer, you can use the keyboard on the bottom. I like to hand type it, but it's up to you. Equals negative, and then you can see X is here. And then this A to the B is the exponent. So you got to put a power 4 there. Plus, plus 4. Now you really want to zoom out until you can see the graph. Okay, and this is probably a pretty good window. If you wanted to get like a little bit squeeze in a little bit on it, you can use this wrench here for the settings. And I can change the x-axis to go from, like, say, -4 to +4. And now we've got, I don't know, a little bit better view of the graph there, something like that. All right. So I'm going to grab that point. Why did I put a pi in? That's really bad. Okay.
I now need to also graph this. I'm not trying not to.
Sorry about that.
No,
All right. So
so,
so there's the graph, and I'm going to go to the other screen here and snip that in, reshare it. And I would encourage you to graph these with me. I probably will have you graph some at some point, just to get your comfort level with it. Okay, share screen. Where am I? Okay.
I'm actually graphing this while you're sharing where you're going to snip it in.
Yeah. Yes. So I've got it in the notes that I'll be sending you after each lesson. So the graph is here. We now need to determine the domain and range. Okay. The domain is the easy one. Until otherwise told, your domain is going to be all real numbers. Okay. And some teachers are okay with all real numbers in words. Some want what's called interval notation, -infinity to infinity. Do you remember from your class notes if there was a distinction made between those? Some even use set notation. Do any of these look familiar to you?
A little bit. I remember the negative infinity and positive infinity because of,
That's the one you'll be using more often in the rest of your courses, so I would recommend we go with that.
Mhm.
Okay, now the range is different. The range in this problem, it's always going to be something for like this: smallest to largest,
Mhm.
or you can think of low to high. And basically you have to decide how far down do these red arrows go? How far down do you think that they go?
Well, because of the arrows, they can go on forever.
Okay, and what do we consider forever down here?
Infinity.
Infinity's up here.
Oh, sorry. So negative infinity.
Yes, a small distinction, but now a parenthesis always goes with infinity or negative infinity. So you never have to do a bracket there. What's the largest? And now we're looking at the y values. What's the largest y value that you see in this graph?
The largest y value.
Yes. What's the only point that I have shown on this graph?
0,4. So
Okay, what's the y value there?
4.
So that is the largest y value. That's your range.
Mhm.
So go ahead and get that down. I think that answers everything. I just need 10, 15 seconds here. I gotta grab a drink. I'll be right back.
All right.
Okay, I am back. Any questions on that or any thoughts, concerns?
Nope, I'm good so far.
Okay. Let's go back and look at the next question. All right, so all right, so here's what I'd like you to do. I'd like you to graph this in Desmos for me. If you have questions, I'll be happy to answer them or talk you through how to do it, but I'd like you to try that. I will also do it in Snip in my graph after you have taken some time to try it on your own.
Mhm. I didn't know Desmos hires people.
Yeah, most places are hiring. Could be a good opportunity for a young math star like yourself.
Mhm. Okay, you need like 1 second.
Sure.
Okay. Y equals 2x to the wrong power. 2x to the power of 3 minus 1. That's a lovely squiggly line.
Okay, I'm going to snip in what I've got. Yours might be different by the color, but can you just confirm that yours looks something like this?
Yeah, mine looks something like that. Mine's just zoomed in for 2. It's in yours
Okay.
is a little more zoomed in.
So important to kind of add some arrows here to show that it goes on forever.
Mhm.
Okay. Now, just like the last problem, the domain, there's no restrictions on the domain yet. Like in general, you don't have to worry about domain restrictions.
Right.
But the range, you may have some issues. Now, you have to decide how far down is this going?
Right.
And then you got to decide, well, how far up is it going?
Right.
What would you say? How would you describe how far down it's going?
Well, it's negative infinity.
Okay. And how far up is it going?
Give me a second.
Okay.
Sorry.
So sometimes the domain and range are exactly the same.
Mhm.
And
Because
there's
we're
really
not
no, go
any
ahead.
numbers.
Say that one more time. I'm sorry.
They're also not giving us any real numbers like the last problem. So
Sometimes they just go up forever.
sometimes they don't.
Sometimes they don't. there really isn't much in the way of work. It's the graph and then interpreting the graph.
Mhm.
Okay, so whenever you're ready here, we'll go on to number 7.
I'm just gonna get a new page ready. I think this is the first time we're gonna finish 2 lessons and technically 2 lessons.
We'll see. We'll see. Be careful here. We don't know what's going to be coming up. All right. So again, probably good to graph this. Let me get a graph of this for you. And if you want, you're welcome to graph it. This is the square root symbol, which they didn't do a great job of showing that, but there it is. 2x plus 8. Sometimes you got to zoom around to kind of find the graph, and that is the case here.
Mhm.
All right, so I'm going to snip this in. And this is what it looks like. So square root functions always start somewhere, and then they go off in a direction.
They
Now,
have a mind of their own, basically.
could be. Now, a couple things about this arrow here. It is going, it is going up forever, but it's also going right forever.
Yeah, so like infinity to the right.
Yes, but it kind of just like what we want it to go. We want it more to go up like this, and it just doesn't look like that. But rest assured, this does go up forever.
Yeah.
Okay. Now this time, the domain is not everything. The domain, more generally, is left to right. And you're looking for the x value. What is the leftmost x value that you see?
Hold on, I'm just trying to catch up.
Sure. Sorry about that.
No, you're good. Left, right. Now, what else? So can you repeat what you said one more time?
Yeah. What's the leftmost x value?
The leftmost, it's -4.
-4. Now it includes -4 because it's a filled in dot there.
Mhm.
Now, how far right does this thing go?
Infinity, so positive infinity.
Infinity. Positive infinity. It goes to the right forever. To the right forever is positive infinity.
Mhm.
The range, again, think of it as the min to the max, the smallest y value to the largest y value. This is the smallest y value here, where it starts. What's the smallest y value?
0.
0. Does it include it? Does it include that? Is it a bracket or is it a parenthesis here?
Parenthesis.
But it includes it, doesn't it? Isn't that a filled in dot?
Oh yeah, the bracket.
So it's a bracket. And then again, how far up does it go? Does this thing go up forever?
Yeah.
It does. It just doesn't look like it.
Yeah.
But it's like the Earth, if we couldn't be in space, we would think the Earth might still be flat because we can't see far enough to know that it actually isn't.
So many people did assume the Earth was flat, and then they got mad at Galileo when he was trying to say, no, it wasn't. So
There are still people that believe the Earth is flat.
I know. I laugh at those people because like,
it's hard to believe, but yeah.
I'm just like, okay, you think it's a pancake.
Yeah, something like that. All right, we're up to 8 now. So 8's going to go pretty fast. 9 is a little slow. We should finish. I'll just say that we should. Famous last words, though. All right. Find the following, showing the steps as done in lesson content. To find f of -7, that means to put -7 wherever you see an x. It means to rewrite it so that wherever you have an x, you put in -7, like that. Is that okay? Is that clear?
Yeah, that's okay. I'm just trying to catch up. My cousin is literally better at math than me sometimes, and she's younger than me.
Well, we all have strengths in different areas. I'm sure you're a much better figure skater than I will ever be. And
you don't want to see the beginnings of it was funny.
But we all have our own talents. And
yeah, I'm just better at history, science.
oh, neat. History is awesome.
Yeah, I like ancient Egyptian and Greek.
Oh,
Type.
cool.
It's more fascinating.
Well, maybe you can visit some of those sites someday.
I have. I've been to Athens.
Oh, fantastic.
Yeah.
All
Okay.
right. Okay, so we've got to simplify now. Order of operations. So we're going to multiply here. 11 times -7 is -77. -7 squared is 49 plus 4. You could probably go to your calculator, your Desmos, and get the rest of this. I'll leave that up to you.
Okay, I'm gonna do this in Desmos. You literally made me.
I think it's helpful. I think it's helpful to use the right tool for the right job.
You are like 3 million steps ahead of me. Oh my god. And I just got on the calculator. Hold on. I'm just gonna have to write this down.
Sure.
really-
Yep. Take your time.
You're like you're a superstar, man.
Well, I'm here to help. I mean, the idea is, eliminate some of the stress and frustration over the math.
Teamwork. Now I will put this in the Desmos. -77 minus 3 plus 4 equals -318.
That sounds correct. Yep, -318. Good.
Yeah.
All right. Any questions on that before we move on?
Nope, I'm good.
All right. So like I said, 9 is just a tiny bit longer. This is kind of something you see in pre-calculus and even calculus.
Uh,
So it's got a bit more work. So it's the same general guidance, which is you take whatever's in parentheses here and you put it in for X,
mhm.
which it's just uncomfortable because you're like, wait, it's not a number. Well, it doesn't have to be. X is now a plus 3 minus 2 squared minus 15. It's okay. It's like, think of X as being in parentheses and it's now a plus 3.
So, okay, this is a weird question, but I've always wondered, what does the F stand for exactly?
It,
Did-
it changes. It's the thing that changes. It could be, in the previous problem, it could be -7, it could be 1, it could be 10. It's a changing value.
Yeah, because I remember when I first started doing pre-algebra and F was mentioned, I always wondered what it it was meant for. Now I know.
So we'll go ahead and get this down. We got to do a little bit of simplifying here to get this finished for the final answer. There's a bit more to do. So we have a plus 3 minus 2 squared minus 15. We're just dropping the parentheses, and then inside parentheses, you can combine like terms. 3 and minus 2 becomes a plus 1 squared minus 15. And then you gotta be very careful here. When you see something like this, a plus 1 squared, what that means is it's a plus 1 times a plus 1. You cannot just do something else, which I'm not even going to say. You've got to do it the way that it's described, which is it's the thing times itself. Okay, so we're at the step here where you're going to FOIL. Like you to try foiling that for us, please.
Okay. A squared plus a plus a plus 1 minus 15. A squared plus 2a plus 1 minus 15. I'm just
Good, doing great. And just combine those constants. And there's your final answer.
yeah, I did it. We did it basically. I can't.
You're doing great. I'm just showing you the steps. You'll be able to do this on your own.
Remember what you said earlier? You're like, don't jinx it. I didn't even jinx us. I was just right.
All right, here we go. Letter D, number 10 here. It says a manufacturer has a monthly fixed cost of $150,000 and a production cost of $18 for each unit X produced. The product sells for $24 per unit. The cost function C of X is 18X plus 150,000, that's C of X. And the revenue function, R of X, is 24X, okay? And if you've been around anyone in business, they talk about profit. Profit is revenue minus cost.
Mhm.
So we're going to use P for profit here. And we're going to take the revenue function 24X and subtract the cost function. Now, whenever you subtract something, you want to pretend like it's in parentheses, like it is here. You're subtracting the entire cost function. If you don't put it in parentheses, you're only subtracting the first part of the cost function. Now, there was a problem earlier where we did this. We had to change the signs, okay, of what's in here. So this becomes 24X minus 18X minus 150,000.
Mhm.
Is that clear how that negative affects both of them?
Yeah.
Great, great. And then from this step, you can combine like terms. You've got a 24X and a minus 18X. Combine like terms and you get 6X minus 150,000. That is your profit function. Unfortunately, real business is more complicated than this. There's not something that's not usually this simple, but for classroom exercises, this is what you get.
It's understandable if it's classroom exercises.
Okay, on to part B. On to part B. It says to use the profit function to find out what the profit will be when 20,000 units are produced. X, oops, why that did that. X is the number of units. 20,000 is the value for X. All right, now this is a little bothersome because the profit's going to be negative. Just look here again. Yep. Okay. Well, that's okay. Well, that's what it is. So here we go. P of 20,000 means to put 20,000 in for X.
Okay.
So this is 120,000. Take away 150,000. So you have a negative $30,000 profit. And that's bad. You don't want to have negative profit in business unless it's a really.
Isn't that how you go bankrupt?
It is, yeah, because if you don't have the money to cover this and your retained earnings, you're going to be in bad shape.
That's how you go into debt and then your business goes.
Yes, yes. So most people that run small businesses, they don't want to have any debt. They don't want to have negative profit. You're not really in business then. You're in business to turn a profit, not to do anything else.
Mhm.
Okay, so good news here is we did finish the assignment, which means that for next time, we can absolutely probably get through an entire assignment. I know that that's kind of the goal, one assignment per lesson. I think when you get more comfortable with the tools and style, maybe even try a problem or two on your own, you're going to see that we're going to get through at least one assignment per lesson on average. So great job today. I'm going to stop the recording.